Good afternoon, everyone. Welcome to this lecture. In this lecture, we'll discuss about base scheduling algorithm. Last class, we discussed about online scheduling algorithm, in which we have discussed 5 different algorithms. One is NET, right? Next is MCT. Okay. Prior to MET, we have discussed about OLB, right? Next, we discussed about KPB. Next, we discussed about switching algorithm. These are the 5 algorithms we discussed. Today, we'll discuss the offline algorithm, or we call it a batch scheduling algorithm. Okay. So here we'll discuss about first algorithm is called as min-min algorithm. Okay. Second algorithm is called first is min-min algorithm. Next one is called as your max-min algorithm. The third one we will discuss, that is called as your suffrage algorithm. Okay. So these are the 3 algorithms we are going to discuss today. Okay. So these algorithms are called offline algorithms. If you compare this algorithm with whatever algorithm we discussed in the last class, you will see in the last class the sequence of the task execution is constant, right? Suppose you have 4 tasks, let's say T1, T2, T3 and T4. So irrespective of these algorithms, that is online algorithms, you are following in the order of T1 followed by T2 followed by T3 and followed by your T4. This order you are following, right? But whenever you come to the offline algorithm, if you are given with 4 tasks, T1, T2, T3, T4, the order is not T1 to T4, like you have seen in the case of online algorithm. So what is the case here? Here you can go for any arbitrary order. For example, one algorithm may suggest you execute T2 first, T4 second, T1 next, then T3. Another algorithm may suggest T3 first, T2 second, okay, T4 third, and T1 last. Similarly, with respect to these offline algorithms, you will find different sequence. So what we are assuming in the offline algorithm, you have a queue, right? Okay, or you can say batch, okay, in which you will keep the request. Then based upon the logic, what you can do, we can remove any element from this queue. Okay, so generally it violates the properties of queue, so we cannot say we cannot call this one as a queue. We generally call it an array. Let us see, it is an array. I can remove any element at any place, right? But if you say a queue, queue says that the deletion should be done in the front and addition to the queue is done at the rear, right? So offline algorithms, you will get better result obviously in comparison to online algorithm, right? Offline algorithm definitely will provide you a good result than online algorithm, because you have the knowledge of all the 4 tasks to take a particular decision. But in the online algorithm, you don't have such facility. What you are doing in online algorithm, you are taking T1 first, you are mapping T1 with the possible resources or clouds or workstations or servers. Once T1 is successfully assigned, then you are moving to T2. Once T2 is done, then you go to T3, T4, like that you are processing the things. But in this case, what you are doing in the offline scheduling case, we assume that all the tasks, that is T1 to T4, are available. All the tasks are available and you can execute them in any order, right? As I mentioned earlier, you can execute in any order, so that you will definitely see that the performance of offline algorithms are always better than the online algorithm, because you know the complete set of tasks and their details, you are aware of that thing, right? So this is the basic difference between the online algorithm, offline algorithm. So today's class will more focus on the offline algorithm, right? So let us discuss the very first algorithm. The first algorithm is called as our mean algorithm, right? As you can see here, there is two mean, one second, right? And you have to read from right to left, right? What it indicates in the step one, these are also called as a two-step algorithm. So in the step one, what you will do, you will apply the first mean, okay? In the step two, you are going to apply the second mean, okay? What is minimum? This mean indicates your minimum completion time, right? Second one also points to the minimum completion time. Both steps points to the minimum completion time, right? But here the mean indicates you have to determine the row value, right? Here it indicates you have to perform the column value, right? Although this means refers to the minimum completion time. So in this algorithm, what you have to do, you have to choose the in the first step you have to choose the minimum element of each and every row. In the step 2, you have to do minimum among the elements selected in the step 1 that is present in a single column. You have to find the minimum of the selected elements in the first step, right? So this heuristic finds the task with the minimum completion time. In the last class, I told you completion time, if you want to calculate, that if you say CT is equal to RT plus PT, right? What is RT? RT is nothing but your ready time, or you can say CRT, that is cloud ready time, and ET is nothing but your execution time, right? If you sum your ready time with your execution time, then you are going to get the completion time, right? You are going to get the completion time. So mean always tries to assign the task based upon the completion time, right? So it finds the task with the minimum completion time and assign the task to the cloud that produces the minimum completion time. Try to understand both things are different. First one, it finds the task with the minimum completion time. First, you have to identify the task which will complete first. Next case, you are going to assign that task to a cloud. It achieves the minimum completion time. That's why in the first page also it is minimum, second page is also minimum. But first page refers to row minimum, second page refers to your column minimum, right? So definitely it chooses the small task first, right? If you take a matrix, if I'll tell you, find the smallest element in the matrix, the smallest element of the matrix, if you want to find, you can follow this min process. For example, one person will say, find the minimum of each and every row. Okay, if you find the minimum of each and every row, this matrix will be converted. This is a big matrix. We assume that the matrix size is minimum 2 plus 2, right? If you find the row minimum, you will get a row matrix, okay, or you may get a column matrix, right? If you reverse this matrix, then if you take represent in different order, you will get either a column matrix or a row matrix. But in the second step, you will get a singular element, okay, or a single element. That single element is the minimum in this particular matrix. If you see the minimum of this matrix and follow this process, in the second step, you are going to get a single element, which is the minimum of the entire matrix. Okay, one person can say that why directly choose without going to the step 1, that is also possible. But you will know the importance of the step 1 in the maximum algorithm, which we will discuss in the next. In this algorithm, you will get the details. In the maximum algorithm, you will see what is the main importance of our step 1. Right? Now, what is the merit you are going to get if you want to apply the min-min algorithm? It is saying if the number of long task means the task size is more, okay, means the task is requiring more time, okay, if such tasks are there. That's why it's saying if the number of long tasks is more than the number of short tasks, then min-min heuristic gives you optimum maximum value, or you can say better maximum value, right? So that is the main thing of the min-min algorithm. Suppose you have 10 tasks, out of 10 tasks, let's say large tasks, the total number of large tasks is 8 and total number of small tasks is 2. So now you see if the number of long tasks is 8 is more than our short task, that is 2. So what I can say, the min-min will provide a better maximum. Although it may or may not provide the optimum maximum, but I can say it will provide you a better maximum. But what is the demerit? The reverse one. The demerit is that if the number of short tasks is more, let's say short task is 8 and long task is 2, then it will result in a very poor maximum. Right? Maximum is not at all good in the min-min algorithm. Also, what you can do, here you can claim that your cloud utilization is also very less. If you result poor maximum, then cloud utilization is also not preferred. Or you can say resource management is also not done in a proper basis. Right? So this is the advantages and disadvantages with respect to the min-min algorithm. Right? Now, come to the maximum algorithm. Before going to the numerical example, let us complete the theory part, then we will discuss. So in the maximum algorithm, I told you, you have to start from the right and you have to go to the left. The first step is minimum. Okay. Second step is your maximum. What I told you in min-min, the first step was step pointing to the row. Second step is pointing to the column. Okay. So what I can say here, this scheduling algorithm is similar to the min-min algorithm because the step 1 of the min-min algorithm and the step 1 of the maximum algorithm are the same. Okay. But it schedules the long task first. Min-min finds the minimum one, right? The minimum completion. Okay. It is also finding the minimum completion time, but it is selecting the task which is a large task, or the maximum execution time that task it is selecting and assigning to the cloud where it achieves the minimum time. Right? What is the merit? Obviously, the reverse one. The number of long tasks is less. Okay. Merit of min-min, demerit of maximum. Merit of maximum is going to be a demerit of your min. Okay. So if the number of long tasks is less than your number of short tasks, then what you can say, maximum strategy is providing a better maximum value than the min-min heuristic. Right? And average cloud utilization is more than the min-min heuristic. Cloud utilization, resource utilization, or you can say resource management, everything is done in a very nice way in comparison to the min-min heuristic. But again, if the long task is more, in that case, if it is referred that you have to apply the min-min algorithm, not the maximum algorithm. But if you apply the maximum algorithm, it will lead to your poor maximum, right? Very poor maximum. That's why maximum algorithm should not be applied in this case, right? Now let us discuss a matrix. So I told you about a matrix that is called as expected time. What you can say, this matrix is expected time to compute matrix. Okay, expected time to compute matrix, which we call it a ETC matrix. Okay, one matrix is given to you in order to run your min and max min algorithm. It is called EPC matrix. Sometimes we will call it a EET matrix, expected execution time matrix, or sometimes we also refer it as a expected completion time matrix. Right? Three are referring to the same thing. Right? So you are given with a matrix, right, in which each and every row represent a particular task, like T1, T2, up to let's say n number of tasks you have, and each and every column points to a cloud, right? So you can say there are n clouds are there. So the time required for each and every task to execute in each cloud is represented in the form of PPC matrix or your PPT matrix or your PCT matrix, right? Okay, PCT matrix is somehow different, you can say, because it is referring to the completion time, it is referring to the execution time, right? So generally we refer ETC and EET, but some where also it is mentioned as ECT, right? But completion time and execution time is different, right? So if you go for min algorithm or if you go for the max min algorithm, what is our first step? The first step is that is your minimum only, right? So what you have to do, once you get this particular matrix, whether you apply the min algorithm or max min, you have to choose a cloud for each task that provides earliest completion time. So out of these possibilities for the task T1, you have to be TN. Which one is TN? No, this is TN. This is not a okay. In this case, you are saying it is TN, okay, and if you are saying this is TN, CN. Sorry, it's okay, right? Because these are variables. You can take M and N, or you can reverse also. There is no problem, right? But you have to ensure that M is much greater than your N value, right? Number of tasks is always greater than the number of tasks. Otherwise, there is no meaning of the task to be algorithm, right? In this case, it is okay. Whatever you are saying, it is okay because here I have used MN, so here the value is M and here the value is M, right? Okay, so you can see here what is our objective is select row minimum. Row minimum means you have to find the earliest completion time for each and every individual task. So here you can see, let us assume that E1 alpha is nothing but the minimum among this E11 to E1n, right? And similarly for the task T2, E2 beta is the minimum among all the values, that is E21. Okay, you can say E21, E22, okay, and E2 and n minus 1, okay, and E2n, right? So similarly, E3 gamma is the minimum one. Similarly, you can say some minimum one for each and every task. That is the first step you have to do if you are applying the min or max min algorithm, right? Once you have done with this one, so what you can do, you have to, this is the whatever we discussed, that E1 alpha, how you will determine, then E2 beta, E3 gamma, up to this, okay? So once the first step is over, if you want to apply the min algorithm, because once you apply the first step, you will get a row matrix, or in the reverse order if you are going, then it is nothing but a column matrix, right? You are going to get. Now, whether it is a row matrix and column matrix, in the next step, you are going to get a single element, which is nothing but minimum of all these things, right? Minimum of all these things you are going to select. That is nothing but it chooses the earliest completion time from the column matrix, right? But this is the simple process, but once you go to the illustration process, you will know the process is little bit complex, but I will tell you with a small example so that the idea will be more clear. So let us go for the first algorithm. First one, let me use paint, so it is better if I use paint. I can easily write. Okay. So okay. Okay. So let us you are assigned you want to assign 4 tasks, that is T1, T2, T3 and T4, right? And let's say C1, C2. Okay. So you have 4 tasks and 2 cloud. Let me use plain pictures. T1, just a minute. Yes. Now it is coming to you. T1, T2, okay, T3 and T4, right? And I am taking two C1 and C2, okay, 2 machines or 2 cloud. Let's say the time what we want to achieve, let's say it is estimated as 150, here it is estimated as 18, here it is estimated as 32, here I have estimated as 7, here it is estimated as 20, here it is estimated as 3, here it is estimated as 50 and 50. These values are just random. There is a process to generate these values, but for the time being, let us assume that these values are random, right? Let me try and do it here so that you are not confused. Okay. So this is the things it is given to you, right? And you have to assign and assume that the ready time, as you are calculating the completion time, assume that ready time of both the C1 and C2 is 0, right? So if you want to perform min-min, right? Let us discuss first the min-min algorithm, then we will go for the max-min. In min-min algorithm, if you want to find the solution of this particular data, what you have to do? First, you have to, the step 1 is you have to find the minimum of each and every row. So minimum of the first row is 18, minimum of the second row is 7, minimum of the third row is 3, minimum of the fourth row is 15. So once you find the row minimum, then in the next step you are going to find the color minimum. So color minimum you are going to get 3. What 3 indicates? 3 indicates that if T3 is going to be assigned into the C2, then it is taking 3 units of time, right? So let me write the solution here, C1 and C2. So as you have decided that T3 need to be assigned to C2, the first order is coming T3. So now you can see the difference between the online and offline algorithm. In the online algorithm, T3 got third chance after T1 and T2. First and second chance and third chance is T3. But here T3 is getting the first chance. So and it is assigned to C2. Right? So once T3 is assigned to C2, as it is, we found this in a two-step process. One step we found the row minimum, another step we found the color minimum, and this value is minimum among all the metrics, entire metrics. Okay, that is obviously if you are not using two-step process also, if you are finding the minimum of these entire metrics, you are going to get 3. But I will tell you the difference in the maximum algorithm. That's why I am going through a two-step process, right? So once you have decided, then you can assign like this. T3 is assigned to 3, and I can remove T3 from my task set. Okay, and this calculation is done, right? Now, once you have occupied 3 units of time in C2, you have to add 3 in each and every cloud, right? In each and every each and every task, whichever is going to be executed in 2, you have to add 3. This 3 is nothing but the ready time. This 3 is also called as ready time, right? So here I am writing the completion time in this format. One is execution time plus ready time. Don't be confused. The first part is your execution time. This ready time is nothing but if there is some pre-occupied slot or if some task is assigned prior to that, that much time it is going to take, right? So once you have done with this one, you have added 3. So you have to again find the row minimum. If you are finding the row minimum, you are going to get 18 plus 3. And second case, you are going to get 7 plus 3. Third task is going to be completed. Fourth task case, you are going to get 15 plus 3. out of which if you want to find the minimum, you are going to get the minimum is 7 plus 3, which is nothing but you want to assign the task T2 to task T2 to C2, right? So if you want to assign task T2 to C2, T2 will come here in the Gantt chart and it is going to take 7 minutes of time. So this 7 is nothing but the execution time of T2 in C2 and this 3 is nothing but the time which is taken by the previously executed task, that is T3, right? So once you are done with T2, you remove T2 from your set and T2 is taking 7 units of time, that's why I am adding 7 here. I am adding also 7 here, right? So now you are finding the row minimum again for the third iteration. You are going to get 18 plus 3 plus 7 is 3 and 7 is nothing but ready time. 18 is your execution time. And task 2 is completed. Task 3 is completed. Task 4 case you are going to get 15 is the execution time and 3 plus 7 is the ready time because of this T3 and T2. So if you want to find the minimum, then you are going to get 15 plus 3 plus 7. It shows that you have to assign task number 4 to your cloud number 2, right? So I am assigning the task 4 to cloud number 2. So how much I will get? I want to 15, right? So if I take 15, then it will complete at 15 plus 3 plus 7, that is 23 and 2, it is going to complete by 25. Now, once you are done with this allocation, what you can do, you have to remove the from the system and you have to add here 15, right? So now if you want to find the row minimum, you are going to get 18 plus 3 plus 7 plus 15 and task 1 is task 2 is completed, task 3 is completed and task 4 is completed. So again you are going to get the same value here because that is only a singular element in the first step. So okay, so in this case you can see you have decided that the T1 is going to be assigned to C2. So T1 will come in the fourth position and it is also assigned to C2. It is taking 18 units of time. T3, 7, 15 is for T3, T2 and T4 respectively. So if I want to tell you calculate the make span of cloud 1, so you can say the make span of cloud 1 is 0 and make span of cloud 2 is nothing but 3 plus 7 10 plus 15 25 25 18 is about it is 43 and if I calculate the overall make span, then you can see the overall make span, the maximum of all the make span of each and every individual cloud. So it is going to, you are going to get 53, right? So I hope this calculation is clear. Can anybody write in the chat box if there any addition mistake? If you have, then please let me know. So you are going to get 43 in this data if you want to apply the minimum algorithm, right? So let me save this file so that I can save it in the later state. Okay, this is the solution for minimum algorithm. Okay, now let us go for the next algorithm that is called as our max min algorithm, right? If you want to execute in the max min algorithm, if you want to execute using the max min algorithm with the same data set, I'm taking T1, T2, and T3, and T4, and I'm taking two different clouds, one is C1, let us give some space to write the ready time, that is C2, right? So, okay, T1, C1, and C2. Now there is a sufficient space. Okay, right? Okay. The initial time is nothing but, as you have seen in the previous case, it is 150, here it is 18, here it is 32, here it is 7, and the next one is 20, and here it is 3, and here it is 50, and it is 50, right? And let me draw the nature in this position, okay? The chart will be right here, moving chart, so that you can see the execution of this task, right? You can see one and two. So what max means do? Max means the first step I already told you that is the minimum you have to find, but in the second step you are going to get the maximum instead of the minimum. That is the only difference between the min algorithm and our maximum algorithm, right? So what you will do here in this case, you have to, okay, I'm writing again, I'm telling, I'm writing CT, completion time is nothing but execution time plus RT. In this order I'm writing, so don't be confused, right? Previously I told you RT plus ET, but this time I'm writing ET plus RT format here so that you will not confuse. Okay, this is the first iteration. Let's say this is the second iteration, this is the third iteration, and fourth iteration, right? In the first iteration, what we will do? Let me write 1, 2, 3, 4 also. 1, 2, 3, 4. Okay, in the first iteration, I will find the row minimum. The row minimum is 18. The row minimum is 7. The row minimum is 3. The row minimum is 15, right? And in the min algorithm, after finding the first step, what you are doing in the second step, you are finding the column minimum, right? But here you have to take column maximum instead of column minimum. If you take column maximum, then you are going to get 18, right? So you are going to get 18 here. So as the maximum one is 18, you are going to execute T1 first, okay? And here also it shows that T1 need to be executed in the cloud too, right? So what I can say, if T1 is dispatched to cloud 2, it is going to take 18 units of time, because initially we assume that the ready time of the both the clouds is 0, right? As I mentioned in the previous case. So this is, you are going to get 18 here. Next, once you have assigned T1 to the cloud 2, let me remove this T1 from the task set. Once you remove this 18 from the task set, then you have to add 18 into the rest of the task while they will execute in the cloud C2, this ready time you need to add, because this much time this cloud is ready. So if you want to find again the row minimum in the second step, first task is completed, second task is you are going to get 7 plus 18. Okay, next task is you are going to get 20. Okay, not 3 plus 18 is your 21, so you are going to get 20. And in this case, you are going to get 15 plus 18 is a row minimum. Once you find the row minimum, what you will do, you will find the column maximum. I hope the column maximum is nothing but 15 plus 18 is the column maximum. Is as 15 plus 18, yes, it is 33, Niraj. So once you determine why I am writing 15 plus 18, the reason is that you will know that 15 is your execution time, 18 is your RT. So once you write 33, what you will do now? In practice, you generally add 33 here. So you may commit mistake, right? That's why I'm writing 15 plus 18. So as you can see here, T4 we are going to assign to C2, right? So T4 we are going to assign to C2. So I am assigning T4 to the C2. It is taking 15 units of time. 15 is the execution time and 18 is the ready time. So 15 plus 18 as mentioned by Neeraj, at the 33 unit of time, it is going to be complete, right? So now it is completed, second step. So I have to add 15 to the rest of the task. So I'm adding 15 here. Yes, I'm adding 15 here, right? So, okay, next one is, you can see here, if you want to find the column minimum, again first task is completed, fourth task is completed, you are going to get the sequence as 7 plus 18 plus 15. Check once. This is 33 plus 7 is 40. So the minimum one you are going to get here is 32, if I am correct, right? So, but in this case, what you are going to get, yes, it is also more, so we are getting 20. So, out of which the maximum one is 32. So, I want to assign T2 to cloud 1. If you assign T2 to cloud 1, it is taking 32 unit of time because the cloud 1's ready time is 0, we have assumed, and no other task assigned to cloud 1 prior to T2, so it is taking 32 unit of time. So once you have assigned this T2 to C1, T2 is removed from the system and 32 I need to add in the T3, right? Because it is in the cloud C1, not in the cloud C2. Now, first task is completed, second task is completed, fourth task is completed, and minimum if you find this is 20 plus 32, I hope it is 52, and in this case you are getting something like 36, right? So obviously this is the minimum, so I am writing 3 plus 18 plus 15, right? So 3 plus 18 plus 15 is giving you 36, and it is the only task. So again, whether you take minimum or maximum, in this case we are taking maximum, you will get the same value, right? So now I am assigning the T3 to cloud number 2. So if I assign task 3 to cloud number 2, it is going to take 3 units of time. So if you determine the make span in cloud 1 is 32, make span in the cloud 2 is 36, right? So if you compare the min and max min algorithm, in min case, if you remember, if I am correct, then 43 is the make span. But if you find the overall make span in the case of max min algorithm, you are going to get 36, right? So in this case, this is a typical scenario where max min performs better than the min min algorithm. But usually, or in general sense, I can say that always the min min performs better than the max min, although it is subjected to the how much task you are taking as a long task and short task. But in a usual scenario, in a normal scenario, generally min min performs better than the max min, right? But this example, max min performs better than the min min algorithm. Okay, let me save this file because I can share with you, right? Okay. So these are the two algorithms and of min and max min algorithm. Before proceeding to the next algorithm, let me tell you another example, and you please try this example. Let us take, you can please note down. You take 4 tasks, that is T1, T2, T3, T4, and C1, C2 times, let's say 2, 4, 3, 6, and 4, 10, and 30 and 70 respectively, right? And you apply the min algorithm, right? You apply the min algorithm, then you apply the max min algorithm and check what is your result, right? So if you practice 2-3 things, then the concept is clear. So you take this as your assignment, right? Okay. Okay. Then we will discuss about the third algorithm, which is a very important algorithm, which is very popular in comparison to the min maximum algorithm. So that is called as our suffrage algorithm, right? So what we are doing in the suffrage algorithm, the suffrage heuristic is based on the idea that better mappings can be generated by assigning a cloud to a task that would suffer most in terms of expected completion time. Just I will tell you this is a non-technical example. So you have appeared the JEE main examination or JEE advanced examinations. So while finding the rank in the JEE main and JEE advanced examination, the problem is that the maximum students, if you see in a particular mark case, So many students secure the same mark, right? A group of students secure the same mark, right? Let's say the exam is for 100 marks. Let's say 10 people secured 93. Now, how I will decide the rank of these 10 people? I cannot give the rank, let's say 93 is the highest mark. I cannot give the rank 1 to all the 10 students. So I have to rank 1, 2, 3 up to 10 only. Because if I'll do rank 1 to all the students, so assume that in some case, if an institute with 5 seats is available, in a particular institute, 5 seats are available. Then who, if all the 10 students are interested to join in that 5 seats, then that will create a conflict, right? So in order to break the tie, people are generally using the date of birth. Many people are using the marks in some XYZ subject. Okay, and there is so many criteria are there in which this conflict can be resolved. Right, that based on that, the rank can be assigned to a particular student. The same concept here we are applying here. It is saying in order to apply the suffrage heuristic, you have to see which task is suffering the most, right? In terms of the expected completion time. Which the task which suffers most is going to be assigned first, right? That is the purpose of this suffrage algorithm, so that you can get a better mapping in comparison to the minimum and maximum algorithm, right? So here you can see it is saying how will you find this suffrage one, or how will you know that whether a task is suffered or not. So for that there is a formula which we call as a suffrage value, right? You have to determine the suffrage value. You have to calculate the suffrage value in order to decide that whether a task has suffered a lot, or or a task has not suffered. That you have to determine, right? So let the suffrage value of the task Ti is the difference between the second earliest completion time on a particular machine My, its earliest completion time machine, that is Ms. For example, task T0 is given three choices, let's say C0, C1, C2, and C3. Then you can see these are called as your machines, right? The C0, C1, whatever we are saying, that is nothing but your MX and My, right? One is MX, one is My. Suppose T0 is taking 10 unit of time here, 15 unit of time here, 25 unit of time here, 60 unit of time here. So if T0 is assigned to C0, it is going to take 10 unit of time. But if T0 is assigned to C1, it is uh, taking 15 unit of time. So it is saying in order to calculate the suffrage value of a particular task, you have to find the difference between the second earliest completion time. The second earliest completion time is nothing but C1, which they represent by My, machine Y. Okay, and its earliest completion time is C0, that they represent as Mx. So once you determine which one is your second earliest completion time and which one is your earliest completion time, what you can do, you will find the difference between the My and Mx, right? The time taken in the machine Y and the time taken in the machine X. So in this case, we will determine the suffrage value as 15 minus 10. That we call it suffrage value. And based upon the highest suffered task, we are going to discuss the task to a particular class, right? So here you can see you are given with four different tasks T0, T1, T2, T3, and you have four cloud C0, C1, C2, C3. So what you did, you have seen that T0, the earliest completion time is 40, the second earliest completion time is 48. In the suffrage value, you are going to get 48 minus 50, which is 8. For the T1, you can say the earliest one is 50, and C1 case, earliest one is 82. So suffrage value is 82 minus 50, it is 32. For T2, 55 is the earliest completion time, 60 8 is the second earliest completion time. The suffrage value you are going to get 68 minus 55 is 13. So T3 case it is 52 is the earliest completion time, 60 is the second earliest completion time, so you are getting 8. So out of these values, you can see which one is minimum, which one is maximum, because we are going to identify the task which would suffer most, right? The suffer most is T1, so I am going to assign the task with T1 to the cloud number C0, right? Because it is suffered a lot in comparison to other tasks, right? So T1 is going to execute first. So once T1 is done, you can say as T0 is assigned to C0, it is occupying 50 unit of time, right? So as it is occupying 50 unit of time, okay, as suffrage is taking 50, T1 is taking 50 unit of time, what you have to do, once T1 is assigned, you have to add 50 in all the values, right? In all these values, you have to add 50, right? So this is 50, okay? Then you find the suffrage value. If you determine the suffrage value, how much you are going to get? This is the highest one is 48 and 50. The suffrage value you are going to get 2. In this case, you are going to get, I hope 68 is the earliest one and 93 is the second earliest one. So you are going to get 25 if the calculation is correct. That is 93 minus 68. In this case, we are going to get 60 and 78 is the first and second earliest machine. So we are going to get 18 is you can say suffrage value, right? So the most suffrage task is your T2. So we will assign T2 as the second one. So T2 you are going to assign to which cloud? You are going to assign the earliest to completion time, that is C1. So you are going to assign to C1. So it is going to take how much time? It is going to take 68 unit of time, right? So once it is done, then what you can do, you can remove T2 from the system and you can add 68 here, add 68 here. Then you again recompute the suffrage value. If you recompute the suffrage value, I hope in the first case the earliest one is 50 and the second earliest one is 90. So the difference you are getting here is 40, right? Similarly, in the last task case, if you find the best machine, it is 78, and the second best machine, if I am correct, it is 52 plus 50, right? 52 plus 50 and 78. The difference between these two, I hope you are getting 24. So you are going to assign T0 as the next task, right? So to which cloud you are going to assign? You are going to assign this to T0, you are going to assign to the C3, okay? And the last one, that is C3, and the value is right? Similarly, if you process T3 case, okay, once T0 is completed, you are going to add 50 here, right? Once T0 is completed, you are going to add 40 in the last task. So the suffrage value you can calculate here. The best machine is 78. Second best is 52 plus 50. Again, the suffrage value is 24. So T3 case you are going to assign to the third machine. Okay, which will get 78. So if calculations are correct, you will get 50, 68, 78, and 40. Out of these, the maximum one is 78. What I can say, the lowest will using the separate algorithm, you can say it is 78. Okay. So in this way, you can assign the task to the different clouds in the offline scheduling, or you can say in the case of batch scheduling, right? So, okay, although a couple of algorithms are there, just I want to tell you these basic algorithms only. We don't want to go through the complex algorithms. But these three algorithms you can practice. In whatever assignment I have given for the minimum and maximum, the same assignment you can apply here the suffrage algorithm and see what is the result. Accordingly, you can draw the Gantt chart. Right? This is the Gantt chart you are going to get. In the suffrage algorithm, you are getting better result in comparison to the minimum. You can use also this data to apply the minimum and maximum and compare whether these results are correct or not.